Okay, welcome everyone. This is just a short, quick intro or overview of the Solidity programming or coding language for Ethereum smart contracts. And you use smart contracts to create dApps, decentralized applications. Okay, so go back here quickly. Solidity is an object-oriented programming language for writing smart contracts. Okay. It is used for implementing smart contracts on various blockchain platforms, especially Ethereum. And it's influenced mostly by JavaScript, C++, Python, and PowerShell. So I'm no expert in Solidity. I'm just giving you a quick overview. There are experts on YouTube. I would advise you to check out some of their channels. And yeah, so let's try and go through this quickly. I'll try and explain some of the code here to you. But before I go there, this is probably one of the best websites that you can use to learn Solidity. Okay, we might check it out in a moment. Okay, so I'm not going to go into detail. I'm just going to briefly from my memory what I understand about the code in this contract. Okay, so this is a voting contract, and they want to try and show the delegated voting functionality. So all Solidity contracts, you start this way. This is the version of Solidity. This arrow means the code is represented or refers to this version or later versions. Okay, without this arrow, it's just this version that the code refers to. And Solidity is still evolving, so it's changing a lot from version to version. Okay, so this is obviously a comment line. This is how you start the contract. Okay, you denote it by the term contract, and then usually capital letter for the contract name and curly brackets. Okay. Struct is short for structure, pretty much, and it's very useful for creating entities or things. Okay, objects, pretty much. So yeah, I can pretty much say that this is similar to an object in other programming languages. Correct me if I'm wrong, but yeah. So struct voter, okay, and a voter consists of these characteristics. The weight in this sense, or in this case, is not the voter's weight, but actually the power or strength that the voter has in terms of either delegating or something related to that. I'm not too sure. Boolean voted, either 0 or 1. If true, that person already voted. So if it's 1, the person already voted, this voter. So struct is pretty much like a dictionary, almost similar to like what you get in Python. I think dictionary is what you call it, and it's weight, because it's got the weight and then it's got the value voted and then it's got the value. So it's similar to a dictionary, if I remember correctly. So address, okay, now these are the variables. Okay, and these are the variable when you define the variable. So this variable is of type unsigned integer. This variable is of type boolean. This variable is of type address. Okay, well, string. And unsigned integer again. Unsigned integer just means it doesn't have a positive or a negative as part of the value. Okay, It's just a positive value or a non-negative value. Yeah, and this is the index of the voter proposal. So yeah, that's not that important. It's just so that you understand how the variables work and their types. The yes and no struct. Okay, and the structs also have curly brackets. Struct proposal. So the similar again to a dictionary. You've got the name and then its value. Name and its value. So bytes 32 is a type of this name. The variable type, and again unsigned integer. So address, public, chairperson. Okay, so chairperson. So here I define a variable, universal variable. Okay, these variables are only defined within this proposal struct, whereas this variable is defined within the contract, so it can be used throughout the contract. I can call this variable from inside a struct, from inside a function. Okay, but I can't call this variable from inside a function because it's local, it's not universal, or global, global. It's a global variable. Public means on the blockchain, on the Ethereum blockchain, this is publicly visible, and at least publicly visible. I'm not too sure about accessible, but this chairperson and its value is publicly visible and accessible when it's relevant, when access to it is relevant, but it's at least the variable name and the value is visible publicly to anyone. Even if you're not the owner of the contract. Address means this chairperson variable is of type address, a string. Okay. Now this is a mapping. Okay. So if I remember correctly, this voters variable, which is also a public variable, public on the blockchain, is of type this. Okay, in other words, it's of type the mapping of an address to a voter, to the voter struct. So this voter struct contains a list of voters. Okay, and each voter has these values. So if you want to refer to a specific voter in this voter struct, then you are going to use this voters variable. Okay, because this voters variable will be attached, linked to an address. Address as defined in terms of the Ethereum blockchain, and it's a long string of characters. So this address will represent a specific voter, and it will point to a specific count. I think it's this one, index of the voted proposal. Anyway, it will have an index in the struct voter, the specific voter, okay, which will be linked to the address. And I'm not too sure if this address and that address is related, linked, or I mean the same address. But yeah, you can check that for yourself. But this is a mapping, okay. So it maps the address linked to a specific voter to the record of that voter in this voter struct, or it adds the new voter value or entry or record into this voter struct. Okay. So this is dynamically sized array, which means so this variable is of type dynamic array, which means If it was fixed array, static array or fixed array, it's one size. But this array is dynamically sized, which means it can grow. Okay, it can change in size, and it's also public. Okay, so proposals. So with every, I'm not sure what this proposals is actually representing, whether it's numeric numbers or votes. But yeah, this is a of type dynamic array and constructor. Okay, so create a new ballot to choose one of proposal names. Constructor is a it's pretty much a function, and I don't remember too well how this is used, so I would suggest you have a look at it yourself. But constructors are extremely important in Solidity contracts. Okay, they are used pretty much every single time in any Solidity contract, smart contract. So also public, so this constructor is of type, it's also public, and it's a constructor function. I just can't remember the exact functionality of it, but yeah, anyway, so as you can see, I'm not going to go through those right now. Chairperson, message.sender, this website, solidity.readthedocs.io, is excellent for learning Solidity, but or reading through, and then you can practice using this website. But you can start on this website. I wouldn't recommend. I would that first. I would recommend that you go through this website first. Okay. So for loop is used. This is how the format that they use in Solidity. Similar to, I think, Python. And then let's see what else. They have the push method, and yeah, you can see this is similar to what a dictionary is in Python. So, and yes, a function, okay, with its variable or its argument variable and the type of the variable, and it's public, this function. And require, without this require, if this require is not met, condition is not met, then this function fails, it exits. Okay, so function delegate public, there again, require again, this function must be met, otherwise it exits. While loop, okay, or while, yes, similar to other programming languages. And if else, and what else do they have in here? For if together, function returns, so this is something that returns a value. Okay, so it's publicly visible and can only be viewed, can't be modified or accessed, can from the public site, can only be viewed, explicitly stated that it can only be viewed, and returns this value. This is important to know what that means. There again. Okay, and this is obviously pointing to an index in a winning proposals somewhere. Okay, so see if we can see something else in here as well. There's another contract, simple auction. So this is an auction contract, blind auction contract. Address of the beneficiary. Yeah, to be able to transact on any blockchain, you need to have an address allocated to you. Okay, so that's a entity, a person, and they've got their own address. Every smart contract also has its own address on the blockchain. Like this contract will have its own address once you publish it on the Ethereum blockchain. This one as well, its own unique address. Okay, so mapping, there's another map. This is a Boolean variable. Event, you have events, so you can listen for events on the blockchain. Okay, any type that you can think of, event to alert you when a transaction has happened, money being transferred, sale has been made, etc., etc. Okay, there's another constructor. Create a simple auction with bidding time, seconds bidding time on behalf of constructor. Okay, so usually the constructors are used to create the actual, so this is the voting dApp, voting contract, and as constructor is usually used to create the actual main part of the dApp, usually. Okay, but you have, as you can see, you have a lot of other functions as well. And in this case it is constructor, proposal, public. So what is it creating here? Chairperson. Okay, so it's coming back to me a little bit. I just wanted to do this video on the fly. So a constructor, part of the function or uses of a constructor is to it's once off. So once you publish the contract on the blockchain, this constructor runs once and not again. So it's actually just to prepare the dApp, once off preparation. It's launch preparations. Once the contract has been published, this constructor, if I understand or remember correctly, it never runs or executes again. Only once, and it's at the time of publishing the contract on the blockchain when this runs. Okay, so everything that you only want and need to run once, and at publishing of the contract, it goes inside the constructor. Everything else here will be used multiple times throughout the contract's life on the blockchain. Okay, same here with this constructor. Yeah, everything inside this constructor will only happen once at publishing of the contract on the blockchain at that moment. So it will create this these variables, and it will assign the variables to new variables, those variables to these, and this is the time. Now this is related to the time. Okay, so this is actually will record when the contract was published on the blockchain, because this will be run at time of publication, and then you will be able to know when calculate when the bidding time end is, auction end is. Okay, with this, and because this only runs once. Okay, so function public payable, this means this payable keyword, or what is this? It's not a method, but this payable means that this function allows payments, okay, in and out. Alright, so require, again you've got those requires, message value, there already is a higher bit. If this is triggered, then it gives you that message. And public returns, the difference between payable and returns, withdraw bit, that was overbit. Okay, returns means when a payment has already happened but the payment must be refunded, then you use the returns this keyword, you use this one, this functionality. Okay, so that the function can accept return values or refunds. Otherwise, without this, it can't accept refunds. Okay, so yeah, so that's a very quick overview. I'm not going to do much more than that. It's a very quick overview, just to give you a basic idea. Okay. And if you want to practice it on your own computer, Windows, you can install the relevant apps and software so that you can actually practice and create actual Solidity contracts. Okay, Ethereum contracts written in Solidity, and you can publish those on the test Ethereum test. I think it's a test net or something, and you can even publish on the main one if you want to. Yeah. Okay, here's another contract, unsigned integer of 8 size, what do you call it, and private, which means it's only visible to the contract owner. Okay, these are not publicly visible like this one. And yeah, okay, deployment. So there's a lot more involved, but if you want to deploy the contract to the blockchain, Truffle is one of the top applications that you will need to use. So you can check all this out, and to get a lot more information about installing Solidity, how to use Solidity, Truffle, so writing tests in Solidity, how to write and deploy a first smart contract in Solidity. Okay, so you can probably refer to, there's quite a lot of resources that you can refer to help you install it. You will need Node.js, npm, Truffle, Ganache, and so on. Okay, so there's a lot of help to help you install it. If you want me to go through, create a video on that, which I might do, then yeah, I will probably do a video on that at some point. So crypto zombies. Okay, it's interactive, and you actually, what this does is you create a similar to CryptoKitties, you create a crypto zombie game, and this is actually a guide to actually help you in a way to create a game, a crypto zombies game. So let's quickly check. Okay, so it's asking you, yeah, put it to the test. Okay, so at some point very soon you are going to see, okay, contract, there you go. Pragma Solidity, enter Solidity version in here and create a contract in here. Okay, and you can refer back to some of the resources I just showed you to help you, but they show you here as well. Contract Hello World, okay, Pragma Solidity, contract Hello World, they actually help you. Okay, so this is a very useful website, and that's the end of this lesson or this video. Just a quick, brief, sort of basic, very basic overview of Solidity. Okay, I hope you found that useful, and see you next time.